So this is the fourth problem. It says, is there any difference in the gestational time for the first and second births of the same parent? So there are 4 moms, and the 2 rows are the gestational times of the first birth and the gestational time of the second birth. Notice that it is the same mom, and we are looking at different birth times. So mom number 1, 2 different birth times. Mom number 2, 2 different birth times. Mom number 3, 2 different birth times. Mom number 4, 2 different birth times, right? Same mom, 2 different birth times. So it's like the same person getting 2 treatments. So this is where it almost looks like it's 2 independent samples. But notice that the first set of numbers, which looks like a separate sample, then the second is coming from the same mom. Same person gets 2 treatments, very similar. So it's a matched pair problem. The sample size is 4. So in the case of a matched pair problem, what happens is we create a new row. And I'm just going to add the new row here since all this is text. So my new row is going to be the difference. First birth minus second birth. So I look at the first mom. First number minus the second number is 2. The first number for the second mom minus the second number is 0. The first number minus the second number is 6. The first number minus the second number is 2. So these are the differences in the first minus the second, and that's what our new variable is. The minute we have a new variable, we ignore these 2 sets of data. We are going to work with this. Now what we've done is we've turned it into a single sample problem where obviously this is a new variable that we've created, and sigma, obviously, which is the population standard deviation, is not given. So in the case of a matched pair problem, we take the difference, and the new row, which is the difference, becomes our new variable x. And obviously the population standard deviation is not given because we created this new variable, so it becomes a single sample t procedure. So if you read the question further, it says that, is there a difference? Is there a difference? That's what is there a difference in the gestational time for the first and second births of the same parent? So how do we answer this question? There are 2 things that you could be asked for. One is a confidence interval. What is a confidence interval? It is a confidence interval is a range of values that estimates the mean difference. So here we are not estimating or finding the mean difference. We are trying to prove that there is a difference. It's a proof. Is there a difference? You're going to answer with a yes or a no, backed up with evidence, which is your p-value. So it's a hypothesis test. Okay. So if the question said something like estimate the mean difference or find the mean difference, that would be a confidence interval. But here it is a hypothesis test, and we're going to work with these data. So the statement in the 4-step process is we will find evidence that there is a difference in the gestational time for the first and second births to the same parent. Where do we get the language from? From the question. So that is your statement. We will find evidence. That's what we're trying to do. Next is formulate. That's your second step. Formulate is explaining which procedure we're going to use. And here is where you have to mention that it's a matched pair problem, and of course your rationale behind that sort of an observation. So since the same mom, it's the same person that are giving us the two numbers, the first gestational time and the second gestational time, this becomes a matched pair problem. Since the same mom is measured twice, this is a matched pair problem. For a matched pair problem, we take the difference in the measurements and create a new variable, which is the difference. And what was our new variable? X, which is the difference? 2, 0, 6, 2. That's the difference in the corresponding numbers. So it becomes a single sample T procedure. So you're going to say we will do a hypothesis test for a matched pair problem. So this is a hypothesis test. Make sure you say these things: hypothesis test, matched pair problem, because same mom is measured twice. We use the formula T equals x bar minus mu o divided by S over radical N because it is a T procedure. Solve, that is step 3. First thing to write down is the null and alternative hypothesis. So these are a data set, which is the difference. The minute you take the difference, it becomes a matched pair problem, right? When the minute it's a matched pair problem, you take the difference, and this is what the null and alternative hypothesis for the hypotheses for the matched pair problem look like. Always, there's a 0 for a matched pair problem. There is no number because we are taking the difference. HO means no difference. There is no difference between the two gestational times. If there is no difference, you subtract one from the other, what do you get? You get a 0. The question says, we'll prove that there is a difference. You're not saying that gestational for the first is greater than the gestational for the second, or the gestational for the first is greater than that of the second, right? You're saying there is a difference, which means the symbol between these two is not a less than, it's not a greater than, it's a not equal to. This says it is a two-sided problem. So the numbers that we plug in the numbers into the formula T equals x bar minus mu o divided by S over radical N. Mu o is 0. X bar, we enter these numbers into our calculator. Use the statistical function to find x bar and S. Okay, S cannot be found in any easy way. Use your statistical function. X bar and S can be found exactly in the same process. So I entered these numbers into my calculator and this is what I got. X bar is 2.5 and S is 2.5166. N is the sample size, which is 4. Enter all the numbers, make sure you have parentheses around this. Although this is a 0, it won't make a difference. You get a 1.97. 1.97 is the T value, but in order to find the P value, we have to go to table C. In order to use the table C, we need to know degrees of freedom. If N is 4, N minus 1, 1 less than the sample size is the degrees of freedom. We go down the row, figure out where exactly our 1.98 lies. So 1.98. So this is how you write your conclusion. 1.98 lies between 1.638 and 2.353. Go down those columns. Look at the yellow highlighted part. You go down to the two-sided p-value because again we have a not equal to, and that's how you get a 0.10 and 0.20. So, so your p-value is, right, the smaller number on the left, the larger number on the right is between 0.10 and 0.20. Whereas your t value is between 1.638 and 2.353. This tells us that our p-value is greater than 0.05. We were hoping that it would be less than 0.05, but what we have is a number p-value, our evidence. There is no evidence. So we fail to reject HO. If we had a p-value that is less than 0.05, then we would have rejected HO, which means we proved our point. So in this case, now we're ready to make a conclusion. Okay, so our conclusion is this. That's step 4. We copy the same language as in the statement, but we're going to say something different. We said we would find evidence, right? But unfortunately, we do not have evidence. So that's how you're going to start your conclude. We do not have evidence, okay, to prove that the gestational time, let me just see if I can write it here. Okay, I don't think it's working, but let's just say conclude will be we do not have enough evidence. And the minute you say the word evidence, write down your p-value, which is between 0.01 and 0.02. We do not have enough evidence to prove that there is a difference in the gestational time for the first and second birth to the same parents, right? So we failed to reject HO. So the way we say it is we do not have evidence.